Greetings, my name is Dr. Beverly Rubik. I'm a biophysicist who recently conducted some pilot studies on smartphone radiation with human subjects, including one with LifeShield's protective products, and I'd like to tell you about them today. First of all, smartphone radiation is really quite a challenge to our health. It's become the main personal electronic communication device, and there are estimated between 6 and 7 billion mobile phones worldwide today. The radiation that's coming out of these smartphones is microwaves, which range between the megahertz and gigahertz frequency range. We know, of course, that high exposures of microwaves heat water, cook tissue, but low exposures can be dangerous too. They cause what we call non-thermal effects. They cause changes in cell membranes. The World Health Organization, or WHO, has found health issues from chronic exposure to microwaves in terms of increased risk for brain cancer and acoustic neuroma. And they've identified a new disorder called electrohypersensitivity syndrome. That syndrome affects between 3 and 6% of the world population rather seriously. Symptoms include headaches, anxiety and irritability, restlessness, sleep problems, fatigue, difficulty concentrating, heart palpitations, and ringing in the ears or tinnitus. In the first pilot study that I did, I looked at the effects of short-term exposure to mobile phone radiation on the blood, and this was done without LifeShields. So my research question was this: does the blood, as observed under a dark field microscope, show any negative effects after human subjects are exposed to a smartphone for a short duration? The study design was exploratory in nature. There were 10 adults between 27 and 75 years old. I used a single smartphone and the same network provider throughout. There were 3 exposure conditions. First of all, baseline without any phone. Then subjects carried the phones 45 minutes in a backpack. And finally, they worked with the cell phone for an additional 45 minutes. I looked at the blood taken from a finger prick and did microphotography of the blood samples using a dark field microscope. The subjects fasted 5 hours prior to their appointments. They also refrained from using a smartphone or Wi-Fi for 4 hours prior to their appointment in the study. And as I said before, they underwent 3 exposure conditions. First, baseline before exposure to the smartphone. Secondly, carrying the smartphone in a backpack called the carrying condition. And thirdly, active use of the smartphone, holding it in the hand, making phone calls, going online, etc. During the active use of the phone, the subjects made phone calls to myself and placed the phone for 2 5-minute periods held to their ears. 3 blood samples were taken from different fingertips of the subjects at baseline, post-carrying, and post-active use. Live blood microscopy can show us many visual features of blood, including the morphology of the red blood cells, white blood cells, the cleanliness of the plasma, whether the red blood cells are sticky or malformed. It's a visual perspective on the ecology of the body. And it can also see various blood clotting factors such as fibrin. One can watch the stability of the blood over time and the integrity of one's cells, the strength and resilience of the biological terrain. I also evaluated the blood for various factors using a Likert scale from 0 to 6, where 0 means none of the factor was present, and I assigned a value of 6 when I saw the highest possible amount present. The red blood cell status in terms of stickiness and aggregation or clumping the formation of rouleaux or rolls of red blood cells, a type of aggregation, the shape of the red blood cells and their integrity, and whether the membranes broke and reformed into what are called cell ghosts were scored. And I lumped together the red blood cell aggregation score, which consisted of stickiness and clumping and rouleau, and also an aggregate score of shape change in terms of changes in the morphology of the red blood cells and membrane integrity. Here's the setup that I use in my laboratory. It's a dark field microscope hooked to a camera connected to a computer, and photographs were taken in real time within the first 10 minutes of viewing the freshly drawn blood from the fingertip. This is how healthy blood looks observed under the dark field microscope. You see here red blood cells visualized by lighting from the side, and the plasma, the spaces between the red blood cells, is clean. And this is ideal blood, rarely seen in these days. Now I'd like to show you the results on the blood for the 3 most reactive subjects in the study. The first subject, a female, 55 years old at baseline, shows blood that shows a small amount of stickiness. The cells are well formed. This is at baseline before exposure to the phone, and after wearing the phone in a backpack for 45 minutes. And after using the phone for an additional 45 minutes, this blood shows drastic changes in morphology. The cells are now extremely stuck together in a formation that we call rouleaux, or rolls of coins. The blood cells are on end like a roll of coins, and you hardly see a single blood cell, just one over here. I also took blood from her toe to see whether indeed this might be systemic or whether it's in the hand that might be holding the cell phone. And indeed we saw the same result of numerous rouleaux, rolls of red blood cells. The second subject, a female 75 years old, shows blood like this at baseline before any exposure to the smartphone. A little bit of stickiness, but the cells are virtually free. The plasma is clear. And after carrying the phone for 45 minutes in a backpack, the cells are in rouleaux, aggregates like rolls of coins seen on end. After an additional 45 minutes of using the phone, holding the phone in the hand and actively using it, the cells of this same subject broke apart but became disturbed in the membranes, which you see spiky cells and cells with disheveled membranes throughout the sample. Now this is another subject, a male, 55 years old, at baseline, shows blood cells that are pretty well separate and well formed. And following 45 minutes of carrying the smartphone in a backpack, this person's cells are now sticky. Some of them are malformed into spiky cells. By and large, stickiness is what is seen. And finally, after 45 minutes of active use of the phone, the cells are entirely malformed in the form of what we call echinocytes, or spiky red blood cells with membranes that extend out into points all the way around, as shown here. So I measured scores, scoring these photographs for red blood cell aggregation and shape changes. I have 2 aggregate scores, and I'd like to show you the final results. Overall, for the 10 subjects averaged for the 2 exposure conditions, the carrying condition, red blood cell aggregation dominated. It was high on a scale from 0 to 6. It was essentially all aggregated. In the carrying condition, shape changes were smaller but still present in terms of loss of membrane integrity for the red blood cells, including the formation of spiky cells. And upon using the cell phone for an additional 45 minutes, aggregation was present, but red blood cell shape change was more dominant than aggregation. In conclusion of this initial pilot study, I found that short-term human exposure to a smartphone radiation produces undesirable changes in the blood. 9 out of 10 subjects showed observable blood changes following smartphone radiation exposure. First, the red blood cells aggregate into clumps, rouleaux, etc., and upon further exposure, these aggregates break down and the red blood cells change shape into disturbed shapes such as echinocytes, spiky red blood cells, and other malformed cells. In the carrying condition, the red blood cell aggregates dominate, and in the post-use condition, deformed red blood cells dominate. This was an initial pilot study, and we showed undesirable changes in the blood as a result of short-term human exposure to smartphone radiation. And what is the cause of this aggregation? Normally, red blood cells, negatively charged, repel one another, and they shouldn't be sticky. So these results suggest that cell membrane potential was reduced after exposure to cell phone radiation. The possible mechanism of action of microwaves on red blood cells. From the literature, we find that low-level microwaves can open up voltage-dependent calcium channels in cells and allow calcium to flow into the cells, as found by Martin Pall in 2013. So changes in calcium inside the cells produce many secondary effects, as calcium is a second messenger. We also see red blood cell aggregation in persons who are not well, in the elderly and those consuming pro-inflammatory diets. Red blood cell aggregation also decreases the microcirculation and increases blood viscosity, so that we see increased cardiovascular risk from this change in the blood. Shape changes in the red blood cells suggest changes in cell membrane permeability and the probability of calcium influx into the red blood cells. We know from the literature that spiky and other deformed red blood cells may be old and are also occurring in certain diseases such as cirrhosis of the liver. It's further known that these echinocytes, or spiky red blood cells, are known to impair oxygen release in the tissues, so there would be issues in peripheral circulation if this condition were chronic. This study was short-term, exploratory, and small, just to look for an effect. It was an exploratory study. However, good controls were employed, the exposure periods were consistent, the levels of exposure were identical for each subject. We monitored ambient electrosmog and kept it low and constant, and we made objective photography of the blood, and the scoring of the blood photos was done by myself, an experienced blood microscopist. The second blood study that I'd like to describe, the effects of short-term exposure to smartphone radiation on the blood with LifeShield's protective products, is essentially the same study design and the same procedures. We used the same 3 most reactive subjects from the first pilot study, the same smartphone and network provider, and we compared 2 conditions, first without LifeShields and secondly with LifeShields. LifeShield's body shield pendant was worn by subjects, and the mobile shield protective device was placed on the rear of the phone over the battery region. And we compared the blood photos for red blood cell aggregation and shape change scores as before. So the results of these studies are shown as follows. Subject 1, female, age 55 at baseline. The blood is relatively normal, not so sticky, little bit of small aggregates. And after carrying with LifeShields, there's a little bit of stickiness, but nothing like it was in the control condition, which you'll see a little bit later. And thirdly, after 45 minutes of additional exposure with active use of the cell phone, protected with light shields, pendant, and the shield on the rear of the phone. The blood is a little bit sticky, a couple of malformed cells. And moving on to the second subject, female age 75 in the baseline condition, relatively normal blood, mostly single cells, a couple of aggregates but very small. And the same subject in the post-carrying condition with life shields, a little bit of stickiness, and after 45 minutes of additional exposure to the smartphone with life shields, the cells are slightly sticky and relatively well formed. The third subject, the male aged 55 at baseline, the blood looks relatively normal with small, very small aggregates. And following 45 minutes of carrying the smartphone in a backpack with life shields, the cells are actually improved, much less sticky, well formed. And finally, following 45 minutes further exposure with active use of the smartphone with light shields, the cells are a little bit sticky and relatively well formed. Now let's take a look at a comparison of the control and life shield conditions for these subjects, so you can see for yourself the difference that life shields made. This is the second subject in the post-carrying condition without life shields, exposed to the cell phone in a backpack for 45 minutes. The cells are essentially all in rouleau, in rolls, no single cells. With life shields, the cells are in loose aggregates. And subject 3, male, age 55, in the post-carrying condition without life shields, the cells were sticky and in small aggregates, and with life shields, the cells are all separate and well formed. And now let's compare the photos of the control and life shields conditions following 45 minutes active use of the smartphone for these same subjects. The first subject, post-active use, 45 minutes of holding the cell phone and actively using it without life shields. The cells are in rouleau, very few cells are free. With life shields, the cells are in loose aggregates. The second subject, female, age 75, without life shields, the cells show malformations, spiky cells or echinocytes. With life shields, there are a few malformed cells. There are no echinocytes and a little bit of stickiness. The third subject, male, age 55, post-active use, 45 minutes of holding the phone in the hand, using it. Without life shields, 100% of the cells were malformed, showing echinocytes, all spiky red blood cells. And with life shields, there were low-level aggregates and very few malformed cells and no echinocytes. To summarize these results in graphs, the mean values of blood parameters without life shields, there were high levels of aggregates in the carrying condition, low levels of shape change, and in the active use condition, both red blood cell aggregates and shape changes were very high. With life shields, the aggregation of red blood cells was very low. It's about 75 to 85% lower, and shape changes over baseline also very small. Again, between 75 and 80% reduced over the control condition. We also measured heart rate variability, measuring the pulse using a finger plethysmograph and performing the Fourier spectrum analysis and looking at heart rate variability in the frequency domain. We looked at specifically the ratio of low frequency to high frequency, which is essentially the ratio of sympathetic to parasympathetic nervous system balance. And we found for the three conditions the following data. In the control condition, the baseline of subject was already elevated in a stressed manner, showing a value of 3.6. The normal healthy value of this LF to HF ratio would be ranging between 0.5 and 2.5. With the Life Shield condition at baseline, it was well within this range, 2.228. After carrying the phone, there was an increase in sympathetic dominance, or the fight or flight response. The stress response was aggravated, and the value in the control condition went up to 3.712. With Life Shields, it was somewhat lower at 3.196. And after using the phone for an additional 45 minutes, the control condition showed even higher sympathetic dominance. The value of LF over HF was over 5, and the value with Life Shields had dropped down to a very healthy level of 0.581, indicating ideal autonomic nervous system balance. In conclusion, when humans are challenged with smartphone radiation for short durations, we found that Life Shields shows a protective effect on the blood. We also found that Life Shields helps keep autonomic nervous system balanced. The sympathetic to parasympathetic ratio was ideal. These results suggest that Life Shields help reduce the stress response in humans challenged with smartphone radiation. For more information, see the Life Shields websites, www.lifeshields.com and www.e-lifeshields.com. Thank you.